65 million years ago. 65 million years ago, that a huge asteroid smashed into the Earth off the... We know that a huge asteroid smashed into the Earth off the coast of Mexico 65 million years ago. We know that a huge asteroid smashed into the Earth off the coast of Mexico 65 million years ago. We know that a huge asteroid smashed into the Earth off the coast of Mexico 65 million years ago. It was traveling at 72,000 kilometers an hour, and when it hit, it released more energy than 5 billion atomic bombs. It wiped out 70% of life on Earth. Of life on Earth. It wiped out 70% of life on Earth. It wiped out 70% of life on Earth. It wiped out 70% of life on Earth. A few more impacts similar to that could destroy all life on Earth. But, believe it or not, Earth is a giant protector.
Jupiter is more than just another pretty face through the telescope. It's actually really important for life on Earth. Jupiter's gravity is so huge, and it's just in the right place in the solar system, that it protects the Earth from comets that come from deep in the solar system and swing by the Sun and could possibly hit the Earth. In the right place in the solar system, that it protects the Earth from comets that come from deep in the solar system and swing by the Sun and could possibly hit the Earth. And it's just in the right place in the solar system that it's important for life on Earth. Jupiter's gravity is so huge, and it's just in the right place in the solar system, that it protects the Earth from comets that come from deep in the solar system and swing by the Sun and could possibly hit the Earth. Gravity is so huge, and it's just in the right place in the solar system, that it protects the Earth from comets that come from deep in the solar telescope. It's actually really important for life on Earth. Jupiter's gravity is so huge, and it's just in the right place in the solar system, that it protects the Earth from comets that come from deep in the solar system and swing by the Sun and could possibly hit the Earth.
Jupiter plays the role of the biggest baseball bat in the solar system. As these comets come by, most of them get knocked out of the solar system by Jupiter.
In 1994, comet Shoemaker-Levy 9 raced towards the inner solar system, but it never got past Jupiter. It never got past Jupiter. Levy 9 raced towards the inner solar system. Comet Shoemaker-Levy 9 raced towards the inner solar system. In 1994, comet Shoemaker-Levy 9 raced towards the inner solar system, but it never got past Jupiter. Astronomers watched as Jupiter tore into pieces and dragged its remains down to the planet's surface.
We have seen comets smash into Jupiter, creating fireballs that were bigger than the Earth.
They were the biggest explosions ever seen in our solar system.
Bigger than the Earth. Creating fireballs that were bigger than the Earth. Smash into Jupiter, creating fireballs that were bigger than the Earth. Smash into Jupiter, creating fireballs that were bigger than the Earth.
the biggest explosions ever seen in our solar system.
Had that comet hit us, it would have resurfaced the planet. It would have been the end of life as we know it.
If Jupiter wasn't there, we believe that the impact rate on the Earth would be something like 1,000 times more than we see today.
We know that a huge asteroid smashed into the Earth off the coast of Mexico 65 million years ago.
Okay, people, I want to talk about this Bennu, yeah? You heard about Bennu, yeah, Osiris-Rex, the NASA's mission to this asteroid. Just reached it on the 3rd of December last year. So I'm gonna show you what I have to say about this, yeah, about Bennu and this mission. But now, just think a little bit what these guys. This is a movie made by Discovery, yeah. So I'm trying to make a point here. Now he's saying 65 million years ago. We know 65 million years ago. Now, man, this is incredible. I mean, this is, people, they start to wake up. How the fuck you expect me to believe you telling me that you know that an asteroid hit Earth 65 million years ago? Man, just think about it, yeah? 65 million years ago. Okay, I will play it again a little bit because it's fun. I mean, it's not fun, but it's...
It was traveling at 72 of Mexico 65 million years ago. Huge asteroid smashed into the Earth off the coast. We know that a huge asteroid smashed into the Earth off the coast of Mexico 65 million years ago. We know that a huge asteroid smashed into the Earth off the coast of Mexico.
Okay, now, how do we know this? Who told us? Who was on Earth 65 million years ago? I mean, even that Big Bang Theory, man, that we used to learn in school, now it makes me laugh. At the beginning, it was nothing, yeah? So after this, a bunch of nothing exploded and created everything. Man, how the fuck people are still able to believe this bullshit? So at the beginning it was nothing, yeah? And after that a bunch of nothing exploded and created everything. This is the Big Bang Theory, yeah? So we don't have a creator, yeah? Nobody created the universe, but it was a randomly Big Bang. But before that, it was nothing. So a bunch of nothing exploded. Do you understand where this is going, man? Do you understand that they treat us like idiots? People must wake up. I don't know what to tell you, you know? I'm laughing because it's funny. I used to learn this shit when I was in school, yeah? So now I'm seeing this and I don't understand whether the rest of the people don't get it. Who the fuck told you about 65 million years ago, man? I'm not talking about 2 years ago, 5 years ago, yeah? 65 million years ago. We know. Who the fuck told you? How do you know this? Okay, let's go further.
65 million years ago. It was traveling at 72,000 kilometers an hour, and when it hit, it released more energy than 5 billion atomic bombs. It wiped out 70% of life on Earth. It wiped out 70% of life on Earth. It wiped out 70% of life on Earth.
Okay, now this is funny also, yeah? So the guy says it wiped out 70% of life forms, yeah, probably, yeah, on Earth. Now, excuse me, I'm trying to watch, I'm trying to see things, yeah, I'm trying to be reasonable here, yeah? 65 million years ago, yeah? Okay, which forms of life were on Earth 65 million years ago? And this asteroid actually wipes out 70% of them. Yes, so basically, it created a big problem, man. Yeah, do you understand this? How the fuck we evolved if 70% of life forms were all wiped out? Huh? Okay, let's go on.
A few more impacts similar to that could destroy all life on Earth. But believe it or not,
Now, this is another problem, yeah? So 65 million years ago, yeah? That asteroid that hit Earth, that we know about it, yeah? Okay. Wiped out 70% of the life form. Now, if an asteroid will hit Earth, will wipe out all the humanity, yeah? So all the forms, all the life forms on Earth, yeah? So listen to this
destroy
idiot.
all life on Earth. But believe it or not, Earth, similar to that, could destroy all life on Earth.
Do you understand? So 65 million years ago, it wiped out just 70%. Now, they are more accurate now, the asteroids, and they learn to wipe out all the life forms on the planet that they will hit. Do you understand this? Man, how people can be so stupid, still believe these fucking idiots giving us false informations about everything, yeah? Okay, now this is Bennu mission, yeah? So now Goddard Space Center explain why Ben. Just listen to this.
Asteroids in our solar system reaching into the hundreds of thousands. Why was Bennu chosen? What made it the best target? The first set of selection criteria was proximity to Earth. The most accessible asteroids are located around 74 to 153 million miles away. And in that group, the most ideal targets are ones with an Earth-like circular orbit and a low degree of tilt due to spacecraft maneuverability. At the time of selection in 2008, that brought the number of known near-Earth objects down from 7,000 to 192. From there, the size of the asteroid became a factor. Bigger meant better in this case, because asteroids with smaller diameters rotate faster, and material on their surface are more easily ejected, not ideal conditions for safely grabbing a sample. So, mission scientists wanted the target to have a diameter larger than 200 meters. That brought the candidates down from 192 to 26. The chemical composition of the asteroid was the next factor, because we want our return sample to help us learn more about the history of our solar system and life on Earth.
Okay, now this is interesting also, yeah? So,
That dropped our
how they
target
choose Bennu, yeah?
That dropped our target list to 12 asteroids with a known composition. And that dropped our target list to 12 asteroids of our solar system and life on Earth. Learn more about the history of our solar system and life. We want our return sample to help us learn more about the history of our solar system. Asteroid was the next factor, because we want our return sample to help us learn more. Composition of the asteroid was the next factor. The chemical composition of the asteroid was the next factor, because we want our return. The chemical composition of the asteroid was the next factor. The chemical composition of the asteroid was the.
Okay, so they said how they choose Bennu, yeah? Okay. Now we are hearing this, yeah? So the chemical composition of the asteroid was the principle, yeah? To choose Bennu. Now, man, I'm asking you, we don't have a sample, yeah? At this time, yeah? So I'm wondering, how do we know already the chemical composition of the asteroid? Listen again.
The next factor, because we want our. The chemical composition of the asteroid was the next factor. The chemical composition of the asteroid was the next factor. The chemical composition of the asteroid was the next factor.
Okay. Who told you the chemical composition of this asteroid? Man, do you understand what these people are doing? And I'm telling you again, yeah, how the people can believe this bullshit, man. Okay, so we have some problems till now, yeah? And the problems I'm gonna show you, it will increase the number of problems. Okay, now we have a composition that we know already, but we send a probe there, yeah, to take a sample. Now, if we know already the composition, why the fuck do we need to send a mission there to take a sample? Okay, let's go.
Because we want our return sample to help us learn more about the history of our solar system and life on Earth. That dropped our target list to 12 asteroids with a known composition. And from there, only 5 of those were ideal for sampling. Only 5 of those were ideal for And from there, only 5 of those were ideal for sampling. And from there, only 5 of those were ideal for with a known composition. With a known composition. Target listed 12 asteroids with a known composition. Target listed 12 asteroids with a known composition. Target listed 12 asteroids with a known composition.
Okay, so they get down to 12, yeah, because they know their composition. Do you understand this? How the fuck do they know their composition? Man, do you understand what kind of shit they are selling to people? And people don't wonder. Listen again, it's funny, man. I mean, it's funny and at the same time.
And from there, only 5 with a known composition. Asteroids with a known composition. That dropped our target list to 12 asteroids with a known composition. That dropped our target list to 12 asteroids with a known composition. That dropped our target list to 12 asteroids with a known composition.
So we have 12 asteroids that we know already their composition, yeah? And I'm asking you again, why the fuck do you send a mission to take a sample if you know their composition? Okay, let's go further.
And from there, only 5 of those were ideal for sampling because they are known from Earth observations to be carbon-rich. This matters because a carbon-rich asteroid This matters because a carbon-rich asteroid This matters because a carbon-rich asteroid means to be carbon-rich. Because they are known from Earth observations to be carbon-rich. Because they are known from Earth observations to be carbon-rich. Because they are known from Earth observations to be
Okay, so they were known from Earth observations, yeah, to be carbon rich, yeah. So they contain a lot of. Now, if you can tell the composition of an asteroid from Earth, I'm asking you again, why do you need to send a mission there to take a sample? Man, I encourage you to, when you have time and you want to laugh, just watch this.
carbon-rich. This matters because a carbon-rich asteroid may contain organic molecules, volatiles, and amino acids that may have been the precursors to life on Earth.
Okay, so I told you it's fun. It's a lot of fun. Try to watch it, you're gonna have a lot of fun like I have myself. Anyway, let's go to some other problems. Now you see this lady. I'm gonna play a little bit from the beginning, yeah, so you will understand.
Hello, space fans. I'm Katrina Jackson with the Office of Communications at NASA's Goddard Space Flight Center. 2 years ago, in September of 2016, OSIRIS-REx launched. NASA's first mission to go collect a sample from an asteroid and return it to Earth. Now it's August of 2018, and OSIRIS-REx is finally approaching its target, asteroid Bennu. So I found a couple people who can explain what the spacecraft is doing during this approach phase and why it's so exciting to get to this point in the mission. It's asteroid Bennu. So I've seen, and OSIRIS-REx is finally 2018, and OSIRIS-REx is
Oh, by the way, I want to show you something, yeah? So, of course, it's logical, yeah? So they choose smart people, yeah?
NASA's first mission to go collect a sample from an asteroid and return it to Earth. Now it's August of 2018, and OSIRIS-REx.
Now, do you recognize this sign, yeah? Okay, she's doing all the time. She's doing this sign, yeah? I want to just point to you this to understand who's talking.
Is finally approaching its target, asteroid Bennu. So I found a couple people who can explain what the spacecraft is doing during this approach phase and why it's so exciting to get to this point in the mission.
What is the approach phase of the OSIRIS-REx mission?
The approach phase is when we reach about 2
million kilometers from the asteroid Bennu. You know, we've been approaching Bennu ever since we launched, but once we reach this period where we're about 2 million kilometers away, that's when our cameras can start to pick up Bennu and see it as a single pixel in the image.
So what will you be doing throughout this approach phase?
Sure. So I'm part of the flight dynamics team, and that basically means I work with a team of highly skilled engineers from Kinetics Aerospace and Goddard Space Flight Center, and we're responsible for navigating the spacecraft. During the approach phase, so we'll take those images, we'll process them, we'll figure out very precisely where Bennu is in those images, and we'll take that data and feed it into our software along with some tracking data from the DSN, range and Doppler measurements, and we'll figure out our best estimate of where the spacecraft is relative to the asteroid and also where the asteroid is relative to the rest of the solar system.
And during this phase, will you be looking out for any sort of hazards around the asteroid, like little moons or dust?
Yeah, absolutely. We have specific science observation.
Hazards around the asteroid, like little moons or dust?
Yeah, absolutely. We have
sort of hazards around the asteroid, like little moons or dust?
Yeah, absolutely.
Sort of hazards around the asteroid, like little moons or dust?
Yeah.
And during this phase, will you be looking out for any sort of hazards around the asteroid, like little moons or dust? And during this phase, will you be looking out for any sort of hazards around the asteroid, like little moons or dust?
Yeah, absolutely.
Okay, man. Now let's stop here a little bit. So she's asking the flight engineer, yeah, what they are trying to observe when they approach Bennu, yeah. So she's asking about the debris, which is understandable. But then she said little moons, yeah. Now, have you ever heard of an asteroid to have moons? I never heard it. Even that asteroid that we know about that hit Mexico 60 million years ago didn't have moons. Now, I don't know if she's stupid, yeah, and how she get to in this position, yeah. But the question, it makes you think of Nibiru's moons, yeah. Now, if you think about this, everything start to have a shape. You understand? A way of thinking. Now we are going somewhere. But to have an asteroid with moons, I never heard about this. Maybe I'm an idiot, but till now, I never heard about this. Okay, let's go further. It's gonna be more fun.
Asteroid that we used as the requirements to design the mission against, but no one could be sure that the asteroid would really look like the scientists had predicted. So it's been a tremendous relief to us to find that the actual Bennu is very similar to what the scientists had predicted. So the science team really nailed it.
Right now, as we're approaching asteroid Bennu, we're looking for debris or other objects that are orbiting the asteroid, just in case we need to avoid those. And then once we arrive on December 3rd, we'll perform preliminary survey. And in preliminary survey, we fly over the North Pole, South Pole, and the middle of the asteroid. This helps us to map the gravity of the asteroid and understand how to operate near such a small body. Additionally, this will be the first time that we get close-up pictures of the surface, and we'll know how smooth or rocky the surface that we're going to study is.
As we get closer to asteroid Bennu, we'll begin to map its surface in higher detail. What we'll be able to do is first identify the distribution of rocks and particles that might pose a hazard to the sampling mechanism on the spacecraft, and we'll also get a better sense of what the shape of Bennu is like at smaller scales. Looking at Bennu in more and more detail is going to help us identify all the areas that we shouldn't go to grab a sample from.
Throughout 2019, we'll be doing global characterization of the asteroid, basically making maps of the entire surface. We're interested in its topography, Are there craters? Where are the boulders, the valleys, the mountains of the asteroid? And then we want to understand the distribution of geologic materials. Are we finding different patches of minerals in one location versus another? And why are certain areas have a composition and others may be different? We're going to be distribution of geologic materials. Are we finding different patches of minerals in one location versus another? And why are asteroid? And then we want to understand the distribution of geologic materials. Are we finding different patches of minerals in one location versus another? And why are certain areas have a composition and others may be different? We're going to be looking most importantly for areas where we can collect a sample.
OSIRIS-REx will collect a sample from Bennu using our TAG-SAM, which is the Touch and Go Sample Acquisition Mechanism. What that is an arm connected to this sampler head that you see here. This is similar in size to an air filter from a car. How this mechanism works is there's compressed gas that is released that will stir up the regolith from Bennu, store it into this canister, which we will then put inside of our sample release capsule and bring back to Earth. We will collect the sample of Bennu in 2020 and return it to Earth in 2023.
Once we're in the vicinity of our home world, about 4.5 hours before impacting the top of the atmosphere, the spacecraft spins up and releases that sample return capsule. The spacecraft fires its engines to perform a deflection burn, going off into orbit around the sun, and the return capsule enters the Earth's atmosphere, targeting a landing in the Utah desert. I'll be there on site when we open that capsule up and we see those samples for the first time, and science begins at that point on the next phase of the mission, the sample analysis period. At that point on the next phase of the mission, the sample analysis period. And science begins at that point on the next phase of the mission, the sample analysis period. And science begins at that point on the next phase of the mission, the sample analysis period.
Okay, now, he's saying the next phase of the mission, yeah? Analyze the composition of the sample, yeah? That they're gonna send to Earth. Now, man, after I watched these movies, yeah? Now, I encourage you to do the same. And then, to think about, you remember the Bruce Willis on Armageddon, yeah? When they were arguing, yeah, on the asteroid, and the other guy says, Captain America, land us on the hard surface of the asteroid so we cannot drill here, yeah? Because it's very tough. Okay, now I've showed you what is funny. Now, if you connect the dots, you understand that, first of all, I don't believe that. Now, which is the problem with Bennu? The problem with Bennu is, I believe they made the calculations, and this asteroid, it's on the collision course with Earth. Now, they are saying this will happen. First they said 2195, now they said 2135. Now, it's a problem here with Bennu, and the real problem with Bennu is Nibiru system. The moons of Nibiru can push this rock towards Earth very quick. So this is the main problem. This is why they are worried about. Problem is, they are worried about the deep underground military bases, yeah? Now, if Bennu will hit in those areas, those underground bases will not exist anymore. Do you understand this? This is their main problem here. Now, what I'm seeing here, to collect a sample, to send it back to Earth, to analyze, and the guy says is not the final phase of the mission, is the next phase of the mission, yeah? So, when you say the next, it means it will be the third part of the mission, yeah? Anyway, this is, I don't know, it's tricky to, I don't know. But this is the way I'm seeing these people, yeah? So, basically, Bennu, it's a real threat for Earth. And number two, Nibiru system can accelerate Bennu on the orbit, yeah? This is the main problem. And they went there, and I believe the third phase of this mission, it will be the deep impact and the Armageddon movie, yeah? Try to send a manned mission there, yeah, a space shuttle, I don't know, and try to nuke this rock, I don't know. Anyway, I believe it was fun. I encourage you to watch this. I mean, it's fun till one point, but then it became serious. And now this is the way I'm seeing things with Bennu, yeah? I believe that they are they're not saying the truth, all the truth, I mean. Okay, guys, have a nice one.